Washington State University. Go Cougs!
Hello everyone. In this video, I'm going to cover lesson 2 of our Working with Activity Data module, and we're going to continue our discussion of data cleaning. So we left off in our last lesson working with the Parkinson's disease healthy older adults activities data set. So let's go ahead and reload that data set into a data frame so we can begin working with it again. Once this is loaded into a data frame, we're going to also continue our discussion of working with missing values. So we saw in the previous lesson that there are some values in our duration column that have question marks, and these question marks represent missing values. So we're going to go ahead and replace these question marks with the special value NaN so that we can use some of the pandas methods built in to help detect and work with missing values. So let's go ahead and replace the question marks with np.nan, and we'll set nplace to true so that these changes are made to our data frame instead of returning a new one. Okay. Now, let's take a look at all of the columns in our data frame just to make sure that the question marks are updated correctly. We have 10 NaNs in our duration column, and there are no NaNs in any of our other columns. So for each column in our data frame columns, let's go ahead and get a series representing this column. And then we're going to print out the series.value counts, just so that we can see each count for every value in our columns. Under this, I'm going to print out the count of the number of NaNs in this column. So ser.isNull.sum is going to tell us that. Let's go ahead and add a label to this too. Number of NaNs. And then lastly, I'm just going to put in kind of a marker so I can see easily the different column information. Okay, so briefly, let's see that there are 9 counts for each participant ID, which makes sense because there are 9 tasks that each participant completed. Number of NaNs is 0. Awesome. Okay, let's move on. Here's the information for task. And here's the information for duration. So for duration, we see that there are 10 NaNs, which is exactly as we would expect because we knew there were 10 question marks, and so on and so forth, 0 and 0. So we've got to think about what to do with these 10 NaNs. We have a few options. The first is to remove the data. So just remove the single row or remove all participants' data that has a row or a few rows that have missing data. The second is to fill the missing values, perhaps by finding similar values in the data set and averaging and using them to fill the missing data. Number 3 is just leave it alone. Later down our data processing pipeline, we can handle the missing data on a case-by-case basis. It may not matter in some cases. We're going to take the first approach just because it's so straightforward and we're not too concerned about losing a few rows here and there. So first things first, let's print out the shape of our data frame because we're going to drop some rows in our data frame and we want to see that change occur. So the first thing we're going to do is df.dropNA in place gets true. So this is going to remove all of the rows that have NaN values. And then we're going to want to re-index our data frame just because we're going to have 10 spots in the data frame where the indices are not going to be sequential, they're going to jump around. So let's go ahead and make a new index. So we'll do np.arrange len of df. So this is our new length after we dropped our null values. And then we can go ahead and set the index to index and do that in place. Okay, so we see before we did the in place drop, we had 675 rows, and now we have 665 rows, which is, as we would expect, dropping 10 NaN values. Now let's get down to working with some of the columns and cleaning them depending on what cleaning needs to be done. So let's start with decoding our task. This is one of the more straightforward cleans we're going to do. So in our previous lesson, we saw that the task values were encoded with integer values, and we had to look up to see, okay, a task value of 1 is water plants, a task value of 2 is fill medication dispenser, etc. So let's just go ahead and replace those integer values with their string representations. And this is going to make it much easier later when we go to visualize this data and we don't need to look up what those task numbers represent. So we'll go ahead and index into the data frame to get the task column. I'll store that in a variable called ser for series. And now for each key in this task decoder dictionary I've already made that maps integer values to string representations, we're going to go ahead and replace every instance of key with the string representation of that key as recorded in our task decoder dictionary. And we'll do this in place. And then let's go ahead and print out, say, the first 11 rows of our data frame after we make this change. So now we see that the task column is no longer integer based, it is string based, and this is really helpful because we can immediately see, okay, participant 0 completed the water plants task in 146 seconds. So this just makes it easier for us to work with. The next thing we're going to do with this data set is we're going to check to make sure that the fields we want to be numeric are actually numeric as specified by pandas. So let's go ahead and check out our duration column. We know that the duration column should be an integer, but we actually see it's an object, which is interesting. Let's next check out the age column, which we know should also be an integer, and see what that says. So that says int64. So the reason why the age is an integer, but the duration is actually an object, is because when pandas went to read this data frame in, there were string question marks in the duration column. We've since removed those, so now we do know that all of these values are integers, but at the time we read it in, pandas didn't know that. So let's go ahead and update the duration column to now actually be a numeric column. So let's replace the duration column with the duration as type, and we'll get an integer type from NumPy. And then let's go ahead and print out the duration again, and hopefully it changes from an object to an integer, and it has. Now the last form of cleaning we're going to do on this data set is we're going to clean the class column. We saw earlier that we have two types of participants in the study, healthy older adults and Parkinson's disease participants, but not all of the participants are coded in a consistent manner. So we might have HOA capitalized or HOA lowercase or Parkinson's disease spelled out or PD, the acronym. There's a lot of different codings that were chosen to label our class, healthy older adult or Parkinson's disease. So we're going to go ahead and work on trying to clean this up so that it's more consistent. And we'll stick with all capital HOA or all capital PD. So let's go ahead and index into our data frame to get our class column. And I'm going to make a copy of this because we're going to be making some changes in place. So now let's walk through each string in our series, ser, and see what's stored in it. So for I in range 0, length the series to 1. We'll get the current string value by indexing into ser sub I. I'm going to convert it to lowercase just so we don't have to deal with capitals being mixed in there. Try to even the playing field here for comparing our strings. And then we're going to implement a simple rule-based system that is going to check to see if some key words are in our cur string. And if they are, then we're going to update our class column to be either capital HOA or capital PD. So let's say if HOA is in cur or healthy, or healthy is in cur, then let's set ser sub I to be HOA. So this is going to handle our lower cases we had and whether it was spelled out. Elif PD is in cur or Parkinson is in cur, then let's set this to be capital PD. Else, this is an unrecognized class label, so let's say unrecognized class label, just so we can see if this is the case for any of our class labels. And we'll go ahead and print it out just so we can see it. And if this is the case, let's just set it to NaN in case we need to drop it later. So now let's update our data frames class column to be ser, since we've been working on a copy, just in case something didn't work out. And let's go ahead and print out the data frame dot value counts so we can see the distribution for each one of our class labels. And hopefully all we have is PD and HOA, which is the case. HOA 446, PD 219. So we just converted our class column to be more consistent in its labeling. So if we index with HOA, we know we're getting all of our healthy older adults. If we index using PD, we know we're getting all of our Parkinson's disease participants. So the last thing that I want to do is write this data frame out to a file because it's cleaned and we don't have to rerun this code for later lessons when we're going to work with this data. So the output file name I'm going to write to is in my files directory, and it's the same name as before, but I'm adding an underscore cleaned.csv. So all I need to do here is df.tocsv, writing to out fname, and I'm going to set a keyword index to false so that we do not write out the index column. I don't need that index column written out because then I have to specify it exists when I read it in. So let's run this. And if I go to that folder, I see here it is, just written out, and I'll take a look, and here is our cleaned data set. And it looks pretty good. Ready for the next stage of our data processing pipeline.